All right, let's do some of these practice problems. So here we have a conversion. We have 57.5 ounces. We have a relationship between ounces and pounds. So let's go ahead and use that relationship. We'll put the ounces on the bottom, the pounds on top. Now we have a relationship between pounds and kilograms, so let's use that. That will give us kilograms. We are multiplying something with 3 significant digits by something that is exact by something that has 3 significant digits. So we are going to want 3 significant digits. So we have 7.91 kilograms. We're trying to convert this price, 3.50 euros per 100 grams, into dollars per pound. First, let's convert euros to dollars. 0.882 euros being $1 with 3 significant digits. Next, we'll cancel the grams by putting grams on top. Our euros cancel and our grams cancel. And the units we end up with are dollars per pound. So we come out with an answer of $18.0 per pound. 17.9996, but we only have 3 significant digits because of a few of our relationships there. So we know this price plus or minus 10 cents, $18.0 per pound. This next problem we already did in the lecture on unit conversions. All right, for this problem 2.7.4, we need to convert 19.3 grams per milliliter into kilograms per liter. Okay, here are some relationships that we can use. 1 kilogram is 10 to the 3 grams. 1 milliliter equals 10 to the negative 3 liters. And for each relationship, we can write 2 different conversion factors. Let's go ahead and convert grams to kilograms using this conversion factor, which will cancel grams. After this step, we will have kilograms per milliliter. Now we need a conversion factor that will change milliliters to liters. Let's use this one that will cancel the milliliters. So now the milliliters cancel and we're left with kilograms per liter. In the numerator we have 19.3 kilograms. In the denominator we have 10 to the 3 times 10 to the minus 3 liters, which is the same as 10 to the 0, which is the same as 1. So 10 to the 0, which is 1. So we actually end up with 19.3 kilograms per liter. And that kind of makes sense because a kilogram is 1,000 times as big as a gram, and a liter is 1,000 times as big as a milliliter. So we actually want to convert a cubic meter into cubic centimeters and figure out how many cubic centimeters are in there. So we need this first conversion factor here, and we actually need it 3 times. We need to multiply it by 1 over 10 to the negative 2 3 times, or raise this to the 3rd power. And that cancels out the cubic meters, and we end up with 10 to the negative 6 in the denominator, which is actually the same as having 10 to the positive 6 in the numerator. So some people might not like powers of 10, and they might know that there are 100 centimeters in 1 meter, just like there are 100 cents in a dollar. Centi is 100. So 1 cubic meter is actually 1 million cubic centimeters, or 1 times 10 to the 6 cubic centimeters. Let's try another conversion with cubic units. All right, let's go ahead and use some of the relationships that I've written here. I've converted each relationship into 2 possible conversion factors. We want to get rid of yards. We have 3 yard units here. So we need this one that has yard in the denominator, and we need that to be cubed because we need to get rid of 3 yards and have cubic inches. Then we need to get rid of inches, so we need this conversion factor here. That also needs to be cubed. And then we need to have this conversion factor to get rid of cubic centimeters. I forgot to write this relationship that 1 milliliter is 10 to the minus 3 liters. Let's go ahead and use that one. So now when we do this, the first step will convert cubic yards into cubic inches. So we'll have cubic inches. Then we'll cancel that and have cubic centimeters. Then we'll cancel that and we'll have milliliters. And then we'll cancel that and we will have liters. So that gives me 1,720.24843 liters. We started with 3 significant digits in our measurement. This is exact, and this is exact, and this is also exact, and this is also exact. So we need 3 significant digits here, so we can just put 1,720 liters. This next one is calculating density. We have the mass of a rectangular block of metal, 263.2 grams. We need the volume so that we can calculate the density. The volume is the length times the width times the height. So our volume is 55.89 cubic centimeters with 3 significant digits, since each of our measurements here has 3 significant digits. When we divide something with 4 significant digits by something with 3 significant digits, we come up with a density that should have 3 significant digits. So we should report this as 4.71 grams per cubic centimeter. Okay, here we have a density problem where the volume is measured with liquid displacement. So we start at 18.5 milliliters as the liquid level, and the volume increases to 35.6 milliliters. That's a difference of 17.1 milliliters. These volume measurements go 1 past the decimal, and so our answer has uncertainty 1 past the decimal. The next step is to divide the mass by the volume, because density is mass over volume. And we have a mass with 3 significant digits, a volume with 3 significant digits. So our final density should be reported to 3 significant digits, or 2.67 grams per milliliter. This next problem is a very similar problem, just that the volume occupied by the solid is not that large. And so when we subtract a number like 18.5 from 25.6, we only get 2 significant digits. Because again, subtraction is based on place value, and these measurements are only known 1 past the decimal. And so our answer is also only known 1 past the decimal. When I do this in my calculator, I get 5.84 grams per milliliter. I'm dividing something with 5 significant digits by something with 2 significant digits, and so our answer should be rounded to 2 significant digits. So it really should be 5.8 grams per milliliter. For these next few problems that are converting either volume to mass or mass to volume, I'm going to be using the density as a conversion factor, but if you want to use one of these formulas, you can do it that way as well. The density relates 1 milliliter to 19.3 grams in the case of gold, and so these are the 2 possible conversion factors you can write for gold. We want to use this one so that we can cancel milliliters. So here the milliliters cancel. We are left with 93.026 grams. We have 3 significant digits in the original measurement and in the density, so we should round our answer to 3 significant digits and report this as 93.0 grams. Okay, so we have 2 possible conversion factors. that the density can turn into in this problem. And since we're converting from grams into milliliters, we're going to want this one that cancels grams. So we cancel grams for this problem. We end up with milliliters. We have 3 significant digits in our mass and in our density. So we'll go ahead and keep 3 significant digits in the answer and report this as 45.4 milliliters. All right, so we are going to try to convert 1 gallon of gasoline into a mass of grams. First, we'll go ahead and convert it to milliliters since our densities have grams per milliliter. And 1 gallon is the same as 3,785 milliliters. This relationship has 4 significant digits, so we could just go ahead and start with our 3,785 milliliters. And then we'll go ahead and use this conversion factor to cancel milliliters. Now our gallons have canceled and our milliliters have canceled, and we're left with grams. So we have 2,834.965 grams. We started off with 4 significant digits. Our density we know to 3 significant digits. So we'll go ahead and round this to 3 significant digits and report this as 2,830 grams. This last one we're starting with grams and we're trying to convert to milliliters. So we need this conversion factor here to cancel the grams. So our grams cancel and we end up with milliliters. We also should end up with 3 significant digits. So this is 18.3 milliliters.